Whenever you're ready.
With the ignition of the biotechnology era, the scope of science has been widened. Biotechnology, according to the New Zealand Technology Curriculum, is defined as the use of living systems or organisms to develop products, systems, or environments to benefit people. Many have proclaimed that biotechnology will be our future, deciding how we evolve and how we will survive. These themes have been regular discussion in science fiction films such as Jurassic Park, Ex Machina, Star Wars, etc. Interestingly, the biotechnology and science fiction film industry boomed at about the same time, 1970. Many journalists and scientists argue that science fiction technology design, whether they are accurate or not, influence technology creation in the real world. But what if it was the other way around? So what if both industries have been profiting from each other's creativity and scientific progress? In short, this is what my research paper is about. Which industry developed first and influenced the other? Hence the dilemma of the chicken or the egg. The purpose of this research is to focus on the extent of how the biotechnology industry has influenced the creation, design, and use of technology in science fiction films from 1970 to 2015. This is an essential question, as the proliferation of science fiction films have been assumed to spread inaccurate scientific knowledge among the general public, sometimes even instilling fear of scientific progress. If we want to know the exact dynamic between the two industries, and if we want to change social perceptions of biotechnology in the future, we need to know how one influences the other. If we learn this, we could actually use scientifically accurate science fiction films to even be used as an educative tool for the next generation. That is why this research is important. So the current gap in the field is that although many people speculate about the effect of science fiction films on the science industry, no articles online or books ever discuss the reverse, so how the biotechnology industry has influenced the film industry throughout the past few decades. There is also no research available that quantitatively shows that sci-fi films actually influence real science. From all the literature review I have conducted, my hypothesis is that there's a correlation between the biotechnology and science fiction film industry. My hypothesis is that the rise of the scientific plot in films must have been influenced by changes in growth and mindset towards science and society. And although science fiction films are usually ahead of the science industry in terms of design and creation of technology, which is why we usually assume that science fiction film technologies are really cool and innovative, they were actually inspired by ongoing technology and scientific advancements. For the purpose of this inquiry, I chose to conduct a correlational study using quantitative and qualitative variables. The study will use quantitative data from the biotechnology and science fiction film industry to show a correlation between the two industries' growth. This will be collecting information on the inflated gross revenue of all science fiction films each year, revenue of public biotech companies, capital raised from initial public offerings, number of films, and number of biotechnology public companies. Then I will analyze them with graphs, linear regression models, and p-value tests to test whether there could be a correlation between the two industries. A more qualitative approach would be to create a timeline charting the first movies with references to a certain genetic engineering technique and when this technique or invention was actually created, to see whether the first inventions were imagined in science fiction films or whether they were already invented in the real world. Since there wasn't quantitative research about either type of influence one industry has on another, I thought this method would be a new addition to the field of research. Using statistics is the most effective and accurate way to show a correlation or association between two variables. The qualitative data is to then solidify the results of the quantitative research. And since one whole aspect of the research question is to see the time difference between a real invention and its introduction into movies, the timeline would be most effective. In my data analysis, the findings will be arranged into two different parts. Part 1 will include the data table and quantitative data along with the graphs showing the correlation. And the other calculations will involve regression analysis, which is a method of finding the strength of a correlation between two quantitative variables, and a hypothesis test, a test which shows whether there is statistically significant evidence to suggest that the science industry has actually influenced the sci-fi industry. Part 2 will then include the qualitative data, which will include the timeline of the real-life inventions and sci-fi inventions. The quantitative data that I have so far is presented on the slides. So this is a data table that I created, which contains the values for the number of biotechnology patents, the capital raised in initial public offerings, which is the first sale of a company's share to the public, according to Investopedia. And there's also the revenue that the biotechnology companies have made. The collection of the data starts from 1970 until 2015. And a limitation would be that there are a few years where I could not find information, as written with the NA. And so this might skew my graph and my analysis. For the science fiction industry on the right, the number of public companies and the number of sci-fi films and the inflated adjusted total gross value of all sci-fi films for each year are mentioned. And for my research, the most important values that I will be using for my analysis is the gross revenue from sci-fi films each year, the NASDAQ biotechnology stock prices since 1993, since that was the first date that was available, the revenue from biotechnology companies, and the capital raised from IPOs. So on this slide, I've taken a photo of the NASDAQ Biotechnology Stock Index, which I'll be using for my analysis. And this is the graph of the biotechnology patents granted by the US PTO, which is also a source for the information in many of my tables. And this slide is the beginning of my analysis. I used a graphing application called LoggerPro, and the axis contains the revenue from, the x-axis contains the revenue from sci-fi films, and the y-axis contains the revenue from biotechnology industries. So as you can see, I used a linear regression model to find the strength of the correlation between the two variables. And in this graph, it seems to be 0.3936, which indicates a weak to moderate correlation. I have used similar regression models to find a correlation between biotechnology IPOs and gross revenues of films, as well as the correlation between biotech maximum stock prices and gross revenue of films. Following this, I will also conduct a hypothesis test called the 1-proportion z-test, which will help me identify if there is sufficient evidence to suggest that the results I see here are because there is a correlation between the two industries and not just because of random chance. So if after my data analysis, there is statistical evidence to support that science fiction film industries in fact have influenced the design and creation of cool technology in films, then in the future we can work towards making science fiction films more scientifically accurate. So soon science fiction films might even be used in education to interest students in STEM while not misleading them at the same time. And the limitation of my research is that I can only show a possible correlation between the two variables, and I can't prove a causation. A possible future study is that a proper study with controlled variables can be conducted in order to prove a causation. And if my evidence does not show any correlation at all, or if the method was not enough to make any sound conclusions, then more qualitative studies can be conducted to analyze the content of many films and find a stronger causation. So considering that science will very likely be the language and future for all of us in the next 20 to 30 years, it is extremely important to know how the movies we all love and run to the movie theaters for might change our future and how we perceive and learn science. Thank you.
Thank you.